So in the chapter of features engineering, so in this video, we'll see what kind of data we have to tackle. Okay. When we discuss the case study, various case study, then we will paste originally in what kind of data we have to paste and what is the drawback of each data and what is its limitations, what it is advantage. We will see at that time. So the now in this video we will now simply introduce what kind of data, what types of data there have in this area, and what kind of features actually we need to handle this data. Okay. So first, most important aspect to the most for a data, the most important, the primary, actually if you think is a primary important aspects is the its featureizations. Okay. After featurizing this data, we can use some machine learning models or some mathematical models onto it. So first thing that we have to always remember, we have to some featureize this data, and after these featureizations we can to apply in machine learning model. So the most important aspect is the features engineering. Okay, in short I have written here HFE, features engineering. Okay, so let's see what kind of data we will see in the case study section. So first kind is called the text data. First, text data. Just in previous chapter we have seen in NLP chapter, and how to featureize the text data means how to convert the text data into a numerical quantity, means in a vector format. So there have already we have already we have learned some technique. Most popular one and most simple ones is the backward technique. Then we have seen EF-IDF technique. Then we have seen average word to vec technique. Then we have seen EF-IDF weighted word to vec technique. This kind of technique we have seen in just previous chapter. Okay, and these techniques are helps us to convert some numerical data, some text data into a numerical data. We have seen this technique, and they have also various featureizations of this text data. Also, they have some featureizations. Actually, we have covered this in NLP, and also we have seen this how to handle these features in deep learning chapter. We'll see, but the main primary concepts we have clear in the NLP chapter. Sure. Now that this is one kind of data, so they have different another kind of data, the categorical data. Categorical. Categorical means what kind of? If you think categorical like means various type of category, means country. If you just country, if you consider the country, then it is one kind of country, means it is India, USA, China, Brazil, like that. It's one kind of category. Okay, and another kind of, you think like as a height of a man. If you just convert this height to a category, like it means tall, very tall, short, medium, like that. This is one kind of category. Okay, these things are actually one kind of categorical data. The categorical data we have means by simply using this categorical data, we have not apply onto it the machine learning models. Somehow we have to convert this category into some numerical features. Then we can apply onto it the machine learning models. So the one most popular one to convert this categorical data to a new vector quantity is one-hot encoding. One-hot encoding. It's the most popular one. And means this, if you think one-hot encoding is look like this same kind of backward technique. We will discuss this thing, but this is the same as the backward technique. Okay, and another kind of thing is the mean response, means based on the mean of this categorical value. So we have to featureize these things into vector format. We will discuss everything in details. So another kind thing is mean response rate, based on mean response rate. The third one, like domain specific, means it depends on the domain, which domain we have to use. It's based on the domain, like that, like this type of, like this kind of main featureizations. We have to use this categorical. We will see these things when we handle the categorical data. Then we will see how to convert this category into a vector format. So another kind of data is look like this type. This is called the time series data. This is called the time series data. So time series data also, there are various kind of time series data. Time series data means the data that we are occupying. It's based on the time. As time changes, the data are also changes its value. Okay, so let's see. So there are various type of time series data. So let's first take it's the most popular one, heartbeat data. And in today's world, everyone we have used the smart bands, smart watches. So in per second, in per means per second, they have capturing the heartbeat for age means age peoples. Okay, so this kind of data is one kind of time series data. Heart rate data heart rate data. Just if you look the plot, if you use, I think all of you now today's world use the smart band, smartwatch. So its data actually it's look like this type, is somewhere here. Like if you make some activities, then this will be high, then sometime it's this kind of data. Okay, this is the heartbeat data. And another one is, you can think like a stock market data. Stock market data also is time series data. So in per second, stock market data is also changed per second. So it's the price of each stock. So if you think this, so sometimes it start from here, and after that, every second it's also all something like that. This type of, this kind of data. That's it. It is the one kind of time series data, stock market. So another things also, e-commerce company. If you just see the e-commerce means predict, if you predict the products and means sales of some products in a hour. So this is the e-commerce data. Sorry, e-commerce data. This data actually which look like this. Here it is the time, and in y-axis we have used the number of trade products that sold in an hour. Sold in an hour. It's look like, means in morning time it's lower. If you think is look like this time, morning time lower, at time increase it's pretty higher. At noon time it's also lower. Evening time, and it's evening and afternoon time it's also increased. Night time it's also decreased. Like this, like this type of, and again it is increase in morning after morning, some kind of clicks patterns. So there. So this is the thing, in e-commerce also use this time series data. E-commerce websites also used in e-commerce world. So the another most popular one is the speech data also. It's very good example, speech data. Means you can think like a audio format data. So this data structure actually look like this. As time here frequency. So this data actually it's depend on the frequency. It's like that. Okay, this kind of data, audio format data. Also, it is a time series. So these are the mainly time series data, and also there are very huge amount time series data. Okay, I think you got the point. What kind of time series? And this text data. If you just see this, you will see these things. This text data is also one kind of sequence of data. It's text data is one kind of sequence of data. It's a sequence of data. Means sequence means they have some sequences of after age what to what. Suppose it's W1, W2, W3 like that. W4 means after some sequence it's occurred like that. It's some sequence of data. Okay. So text data is also sequence of data. And the most now in this world, in this deep learning world, the most popular data one is the image data. Image data or video data. You can think like image data. So the image data, you can the actual use of image data means in face detections or in face recognitions. Mean in a image they have some face or not. In a image, if they have some faces, then which the face is in which face it is. Okay, so that's kind of thing actually useful. But means features are actually in is image data. So face detection like face recognition. We'll see when we'll learn the deep learning how to handle this image data. We'll see in details. But now just take the concept. Recognitions, and also there are various kind of in medical domain. If you just think image data also very important in medical domain, like X-ray data, also image format, MRI scans, and video also combinations of the image data. Video most popular one. Video also. So these also means a video. Just if you just think this video as one kind of time series data. Okay, here we have time, and here combinations of images. So this is the actually it's when time progress, the sequence of images actually we have taken here. Okay, after another image. Okay, so video is one kind of sequence of image data. Video is sequence of image data. That's the sequence of image data. Okay, so now the questions is text image is a data, but somehow we have to convert this image data into a numerical data, then onto it we can apply the ML models. So much the most challenging part is because now students was image is a huge one image is today. Well, I think this camera now today's the mobile phone, the camera is 18 megapixel, 64 megapixel, 48 megapixels camera they are, and one image occupy the 12 MB to 15 MB image size. And you can think the 4K video, a huge amount of that means huge amount of size means what? The pixel are so huge that the size of the matrix, the size of the numerical quantity is so large. Now the most challenging one is how to convert this huge amount of pixels into a small length vector. That's the most challenging and most interesting topics of the research now today's world. numerical one. Okay. Most challenging one. Challenging part. Okay. And after, if we just convert it numeric image to numerical, then after onto it we can easily use the ML, some ML models. It could be supervised learning model or unsupervised learning models, anything as our requirement we can use. But the most challenging in how to featurize this image data and how to convert this so huge amount of pixels is into it numerical quantity. Somehow it's not lost some informations of that. That's the most challenging. Now also there have the data sets like a database table. Means if when we learn the MySQL databases, then we can see. So it's also most important in our today's world. The database tables. Just if you think about the database tables actually look like this. Means on kind of tables format. It's depend on the situations which are our requirement. Suppose let's is the tables of the suppose I am taking about the e-commerce website, some e-commerce website. So in e-commerce website, for increasing the sales, they need various kind of data for each customer. So suppose the customer's information, what the locations of the customers, and what kind of product they have mostly visited in their websites, and in which product they have more invested their time, and in which locations, from which locations they watch this product. Okay. And now, and another best is in what kind of price range product they have searched, and what is its search history. Various kind of features actually they have for increasing the sales. So if for a single customer, if you write all the features in a single row, it's actually the size of the data sets is so be huge. So they are have a one kind of concept, database concept. Okay, database. So when we learn the MySQL database, then you can see in every things in details how to handle this kind of complex, every log of a particular patients, how we will understand this thing, how to store these things. We will see this thing. But now the database size is actually look like this type. Suppose let's this is I am taking here e-commerce website company. E-commerce website company. Suppose let's it's a customer table. Suppose let's take customer tables. So suppose let in this table that data we have stored customer ID. For each customers there have also ID, customers ID, and corresponding the addresses of this customer. Okay, there have various address, maybe address 1, address 2, like that. There are, if there are possible various address. This is one kind of tables. Also there have another tables in the database. So the edge customers that we have, instead of writing here the suppose let's these tables are actually, suppose let's purchase tables for each customer. Purchase tables. Okay, in these purchase tables there have the customer ID, and here the purchase ID, and the main thing, one important thing is in a time, which time they have purchase. Time also very important. It's time series data actually. So actually in a single customer there have mainly 2 or 3 addresses, but the product they have purchases is, I think just in average, if you consider for Amazon case, in average time we have seen that the purchases time for average customers is 10 to 12 times. Okay, if you just for a single customer, if you just increase this thing, increase this purchase ID and time, so the diamonds, so that just see this dimensional to be increased. So instead of writing here we will use this another table for purchases. Okay, these are the things. And also there are another kind of table. It may be product table. Here it is the product ID. What is its price? What is its description? Like that, description like that. These things are called the product table. Product tables. So instead of writing the product ID details in that tables, it will be better if we make separate tables. Based on our requirement, for each customers we can find its product ID, and for each product ID we can find the details from these tables. So these are the actually called the relations database. Relations, just see it. Age and age, just see the relations here. In these two tables, there have these relations. In these two tables, there have these relations. So age tables are relations to another table. These things are called the relational database. These are the relations. So you will see in my school chapter in details. But these are the, and they are one most important data set also. They are graph data. Graph data. So look, let's throw an example. Suppose we are all out today's world. We are all use the Facebook. If you consider Facebook, in our Facebook ID, they have some friend recommendations. They have case which friend they may be our mutual friend, something like that. So these friend recommendations actually based on this graph data. So suppose let's the in the graph there have two things we need. One is the vertex, and one is suppose this h. So suppose let's we have four users they have in Facebook. User 1, user 2, like user 3, like user 4. So there are four users, and suppose let this user 1 and user 2 are the friends, and user 1 and user 3 are the friends. This blue line is actually talking about friend. It's the friend. Okay. And also u2 and u3 are the friends. u2 and u4. Sorry, u2 and u2 and u3. Suppose let actually these two guys are friends. Now we have to and somehow let these two also u2 and u4 are also friend. Okay, u2 and u4 also friend. Now the questions, now we have to make some relations that may we suggest that u4 are friend with u3 or u1. Actually the seed u4 only friend of u2, and u4 is not friend of u1 and u3. So from this graph, can we suggest that u4 may be some chances of u3 or u1? Since see it, just I am taking a different color, yellow color. So just see it, u4 is the friend of u2, and u2 is the friend of u1 and u3. See it, and u1 and u3 also friend. So there may have chance, since u4 is a friend of u2 and u2 is a friend of u3. So there may have a chance that u4 may be some friend of u4, and also since for u1 also, since u4 is a friend of u2 and u2 is a friend of u1, so there may be a chance that he is also mutual friend. Okay, such kind of actually they have some calculations algorithms they have. So means this kind of techniques are used in the in graph data. Okay, these things are called the graph data. So here from this picture we can suggest that u4 may be friend of u1 and u3. So I think you have understand the graph data how useful. So the main the questions that's come into our mind, how to features, how to convert this graph data into numerical data. Unless we have not convert this graph data into numerical data, so we cannot apply the ML algorithms onto it. So the main questions that is how will convert this numerical data into a how to convert this graph data into a numerical data, into the numerical data. I will convert these things, and after converting it we can easily apply some ML algorithms onto it. So now this is the main challenging part is comes onto here, and what kind of features that we have to take from edge users, how to convert its graph data into our considerations. So for edge users there are various kind of features. These features may be the school level, these features may be based on this locations level, these features may be based on their interest levels. Okay, I mean these kind of things are actually needed. So this is the most challenging one, what kind of features actually we need to choose for edge users to recommend it someone, maybe some mutual friend. Okay, so these are the things actually, these are the graph data. So there have lots of not only this, I am using this most popular one on the machine learning, but there are tons of huge, there are tons of types of data, there are tons of types of data. Okay, these one are the most popular one. So the in the data, the most challenging one is to convert this data into a numerical. So we need to featureize it, we need to select the feature, select the proper features and right features in based on our situations. Okay, so these are the most commonly used data sets in the real world, and there have also lots of tons of types of data. So but the main in this chapter, the main target is main target, the main key point of this chapter is we will learn here in this chapter the featureizations, how to featureize this kind of data, and most commonly featureizations techniques we will learn here. So the main thing that we are going to learn here, all the featureization technique. All the featureization techniques we will learn here, and the mostly covered here are most commonly used featureization technique. Here most technique we will most commonly used, we will learn. Or actually in a single chapter and single times it is not possible to cover all the techniques, and actually the main thing is that it's depend on the problem to problem. Based on the problem we have to choose the right featureization. But in this chapter we will try to learn the most common used featureizations that in general we have used in the real world data. So in next video we will see how to take the features, right features for right.